Hi, this is Alex from devstories.eu, OpenClaw Gateway, episode 10 of 11. You ask your AI to scrape a complex website or crunch thousands of log lines, and then you just sit there. You stare at a spinning indicator for 10 minutes, unable to ask another question until the task finishes. To fix this blocking problem, you use ephemeral subagents. An ephemeral subagent is a temporary, isolated background worker. Instead of doing the heavy computation itself, your main chat agent delegates the work. It does this using a specific system tool called session spawn. When the main agent encounters a massive task, it triggers this tool. It passes along a clear prompt, any required context files, and the specific instructions for the job. This action creates a completely new, invisible chat session running entirely in the background. Because this session is isolated, your main agent is immediately freed up. You can keep talking to your primary assistant, ask unrelated questions, or assign more tasks while the subagent grinds away at the heavy data out of sight. Let us look at a concrete scenario. You drop a massive server error log into your main chat and ask for a security audit. Processing that log line by line with your primary heavy-duty LLM takes a long time and burns a lot of expensive tokens. Instead, your main agent delegates the job. Here is the key insight. When calling session spawn, the main agent can specify a completely different model for the background task. It can assign a cheaper, faster LLM to the subagent. This background worker uses the faster model to chew through the repetitive log analysis. The main agent stays responsive using the smart model, while the subagent does the grunt work using the fast model. When the subagent finally finishes parsing those logs, it needs a way to hand the data back. It does this by announcing its final result up the chain. The subagent takes its compiled summary and injects a message directly back into the original requester chat. You just see a new message pop up from the subagent with your completed log analysis, ready for you and the main agent to discuss. This architecture is known as the orchestrator pattern, and it relies on rules around nesting depth. The scenario we just covered is nesting depth 1. The user talks to the main agent, and the main agent spawns a subagent. OpenClaw also supports nesting depth 2. In a depth 2 scenario, your log parsing subagent might encounter a heavily encoded payload in the logs. It can then spawn its own subagent just to decode that specific payload. That second-level agent decodes the text, passes it back to the first subagent, which then completes the log analysis and reports back up to your main chat. The system strictly caps this at depth 2. This hard limit prevents runaway recursive loops where agents continuously spawn other agents forever, draining your compute resources. Ephemeral subagents fundamentally change how you interact with a prompt interface. You stop treating your LLM like a single blocked thread and start treating it like an asynchronous task manager. That is your lot for this one. Catch you next time.